Alright, in this video I'm going to do an example of an ultrasonic sensor. We're using these a lot in robotics these days, and what you realize when you're doing computer programming for the ultrasonic sensor is that you have to put in some sort of speed of sound. And so when you do that, you're assuming a specific temperature. So as long as the ultrasonic sensor is working at that temperature, everything will work out. But if the ultrasonic sensor is in a different environment with a different temperature, it's going to be using the wrong speed of sound. So let's look at what that might cause in an example. An ultrasonic sensor uses sound waves to measure the distance of objects. If a pulse is sent out and reflects off of an object that is 5.2 meters away, to determine the length of time it would take for the sound pulse to return. Assume the sensor is being used outside on a day where the temperature is minus 10 degrees Celsius. If the sensor is designed to work at 21 degrees Celsius, how far away will it think the object is? Well, if we just do a little thinking about this example first, what we're going to realize is if it thinks it's 21 degrees outside, then it's going to think that the speed of sound should be faster than it is. So however long it takes, that's going to be longer than the sensor thought it should have taken. So what it's going to assume then is that this object is further away than you thought it was. Let's find out the time, and let's just see exactly how much of a difference this makes. So first things first, we're saying the object is 5.2 meters away, which means if we want the time for the pulse to go and come back, that means the pulse is going to have to go there and come back, which means the total distance it's going to have to travel is 10.4 meters. It assumes the temperature outside is negative 10 degrees. So let's use that to calculate the speed of sound. And in this case, that's going to work out to 326 meters per second. And again, the speed of sound is constant, so we can use the uniform motion equation. V equals d over t to solve for time. 326 meters per second, 10.4 meters, t, multiply both sides by t, then divide both sides by 326. I got a 0.0319. So for the pulse to go out and come back, because the temperature is 10 degrees Celsius, it's going to take 0.0319 seconds. That answers the first part of this problem. But now the second part says, the sensor is designed to work at 21 degrees Celsius. How far away will it think the object is? So what that means then is that the sensor thinks that it's 21 degrees Celsius. So the sensor thinks the speed of sound is 344.6 meters per second. Now the time it took to go and come back was 0.0319 seconds. So again, the sensor assumes that the sound is traveling according to uniform motion at a speed of 344.6 for a time of 0.319 seconds. I multiply both sides by 0.319 seconds. And I get a distance of 10.99 meters. Now, recognizing that that's the amount the sensor realizes that the thing should have gone and come back, that would be the total distance. For the actual distance to the object, it will be that divided by 2, which works out to basically 5.5 meters. So the object is actually 5.2 meters, but due to the fact that it's operating at a different temperature than it would expect, it measures it to be at 5.5 meters.